In this video, we're going to start talking about something called a ratio, and we're going to talk about how we write ratios, how we simplify ratios, and how we order ratios from least to greatest. So let's start by defining the word ratio. A ratio uses division to compare two quantities. And I'm going to explain that last little part in parentheses in a second. But it uses division to compare two quantities. Now, there are three main ways that this can be written. First, oftentimes I'll say a ratio is A over B. So you can see that this looks directly like a fraction, which it pretty much is. So a ratio can be written like a fraction, A over B, and you'll notice it says B cannot be equal to 0. So that bottom number right there in your fraction cannot be equal to 0. Because if you do that and you try to divide it in your calculator, you'll get an error. The second way that these can commonly be written is using a colon. So they would say A to B. This is saying the same thing as the fraction. It's just written in a slightly different way. And then the other way we can write it is actually writing the word 2 in between as A to B. So you can see here we have three main ways that we write ratios. The first is the fraction, that is the most commonly used way. The second is using the colon, and the third is using the actual word 2. So now we're going to practice writing ratios given a situation. So here we can see Mrs. Conway's swim team has 14 swim meets this year. So there's a total of 14. 8 of these swim meets were home. Find the following rates. So this first rate here in rate A says you want to find the rate of home meets to away meets. So when I look here, I can see that 8 of these swim meets were home. So I know that there are 8 home meets. And then 2 away meets. Well, it doesn't tell me how many away meets there are, but it tells me there are 14 total meets, and there are 8 home, which means that there have to be 6 away meets. So we have 6 away meets. Now here, what you need to note is that the order does in fact matter. So the 8 has to be equal to your A value, because that's first. And the 6 has to be equal to your B value, because that's second. So we can write our ratio in any of the three ways that we listed on the previous slide. We could say 8 to 6. So this is home to away. You can see they give it to you in the instructions. You could also write this as home to away or home to away. So you can write it in any one of those three ways as long as the 8 comes first since it's before the word to, and the 6 comes second. Now in the second part, in part B, we can see that we have the ratio of away meets to all meets. So I know that away meets is 6 and all meets is 14. So again, order matters. So we'll do 6 to 14. That's away to all. Or you could write it using a colon, 6 to 14, or 6 to 14. So either one of those three would work. Then the last one here, we have the ratio of all meets to home meets. So all is 14, and that's first. Home meets are second, and that's 8. So again, the order does in fact matter. So we have all to home. So we have 14 over 8. That's one way we could write it. 14 colon 8 or 14 to 8. So again, you can use any one of these three ways to write it, but the order does matter. That first one that's mentioned needs to come first. Then the word to is where your fraction, your colon, or your word to appear. And then that second number comes second. So now that we know what a ratio is, let's practice simplifying them. And this should be something that is pretty simple to you because you've actually done this quite a bit in pre-algebra class. So here I'm going to start with part C because that's probably the one you already know how to simplify because it looks like a fraction and we've simplified fractions. And as you simplify ratios, all you are looking for is a common factor that both numbers are divisible by. So for example, when I look at 36 and 12, I can see that they are both divisible by 6. So I start by dividing both of them by 6, so I end up with 6 over 2. Then I can see they're both still divisible by a common factor of 2, so I divide them both by 2 to get 3 over 1. So simplifying ratios is essentially the same thing as simplifying fractions. We just need to find common factors between the two numbers until there are no common factors to divide by anymore. So now let's go back to A, and when I look at A, I see 6 and 24. And what I notice here is that I have 6 and 24 are both divisible by 6. So if I divide both by 6, I end up with 1, 2, 4. And if it's a little confusing to look at it that way, you can always turn it into a fraction. So you could turn it into 6 over 24, and then simplify it to 1/4, and then simplify it back to its original ratio type. If I then look at B, again, remember you could turn this into a fraction and then simplify it. But what I do notice about 28 and 21 is they are both divisible by 7. So if I divide them both by 7, I end up with 4 colon 3. So those are my simplified ratios. And again, this works just like simplifying fractions. You're looking for those common factors you can divide both numbers by until they no longer have a common factor in common. So now we're going to use this same type of simplifying thinking to determine whether or not ratios are equivalent. And really all we're going to do is turn these into their simplest form and determine, are they equivalent ratios, yes or no? If they are equivalent, they will simplify to the same fraction, essentially. So here, 15 over 6, I notice that both of these are divisible by 3. So I divide 15 by 3, that's 5. 6 by 3, that is 2. I then look here at 10 over 4. I notice both of these are divisible by 2. So that simplifies to 5 over 2. So these are, in fact, the exact same ratios because they simplify to be the exact same fraction, the exact same number. If I look at this next one here, what I notice is that 35 and 7 are both divisible by 7. So 35 divisible by 7 is 5. And 7 divided by 7 is 1. If I look at this next one, they're both divisible by 5, so I get 1 over 5. While those look similar, 5 and 1/5 are not the exact same ratio. They are not the same. They may contain the same numbers, but they are not the same. So here we can see by our simplifying that these are in fact not equivalent, and as a result are not the same simplified fraction. So now let's look at how we actually order ratios from least to greatest. So here you can see that we have 1, 2, 3, 4, 5 different ratios. And what I notice is that they're written in all different ways. So what I like to do when I first start ordering ratios is I like to go through and I like to put them all in the same form. So I like to start off by saying, okay, I'm going to write them all as fractions to start. Write them all in the same way so I don't get confused. Now, what I notice here is that these fractions are still somewhat difficult to compare because they all have different denominators. So what you could do is rewrite each of these and determine what their common denominator would be for all 5, and then convert them all. That's one thing you could do, which it would take a little while, but you could find a common denominator. However, what I like to do is use my calculator and figure out what each of these is equivalent to, just as a number with a decimal. So if we look at each of these, what we're going to do is we're going to turn it into its decimal equivalent. You might be thinking, how do we do that? But if you have your calculator in front of you, all you really need to do is use division because these fractions are all just division. So if I look at this first one here, I see 209 over 30. So if I take 209 and divide it by 30 on my calculator, I end up with 6.97. So that one's a pretty large number, actually. If I look at the next one, so the second one here of 36 over 9, if I take 36 divided by its denominator of 9, I get 4. If I take this next one here, 47 divided by 12, I end up with 3.92. If I take that next one of 9 divided by 2, in my calculator, I find 4.5. And then that last one of 83 divided by 8, I end up with 10.375. So looking at them as decimals really helps me to see which number is the largest actually and which number is the smallest. So this says to order our ratios from least, which means the smallest number, to greatest, which means the biggest number. So we're going to start with the smallest number, and if I look at my 5 options down here, so I have 1, 2, 3, 4, 5 numbers, my least or my smallest number is right here at 3.92. That's the smallest of the 5 numbers I see on the screen. So what that's telling me is that this ratio right here is first and is the smallest. So I'm going to go back to my original ratios and write, okay, the first one, the smallest ratio, is 47/12. So then I've taken care of that one. And then I look for the next smallest number, and I see that 2 of them contain a 4. So I have to think, okay, which one of these 2 is smaller? Well, the smaller of those 2 would be 4, because 4.5 would be a little bit bigger. So this ratio of 36:9 is second. So that's what I'm going to write next, and I'm just going to separate them by commas. So I have 36:9. So that one's taken care of. And then notice my next smallest is my other number containing a 4, so that's 4.5. So that would make 9:2 my third smallest ratio. So that comes next, 9:2. I can then see that my next smallest would be the 6 right here. So this would be fourth of 209 over 30. And then my largest ratio is down here at the 10, which means that this 83/8 is my largest ratio. So there we have it, all of them in order from least to greatest. So as I said, the easiest way I think to do this is to convert them all into the same ratio type of a fraction, and then divide that fraction out and order those decimal values.